So as we do things today, we're going to be working on calculating the specific heat of different metals with lab, finishing it up. That's still standard 4, objective 2F. We're going to correct 7.4, but before we correct it, we're going to go through a few things. We're going to go through the stuff that you need to know for the lab, and then we're going to start the speed dating with the review. We are going to correct the review at the end of class. There is a test next time. Yes? No. Sorry. Okay, so let's go here for just a minute and talk about, whoops, didn't like that, and talk about number 2 on your assignment and number 6 on your assignment. This assignment, number 4, is a lot like your written part of the test. So you need to make sure that you understand it, and you need to make sure you're telling me if it's positive or negative for Q. So on number 2, on your assignment, most of you will probably get most of it right. The problem that I'm having is as you're pulling stuff out, it says graphite has a specific heat of, so most of you know that's CP, of 0.709 joules per gram degree Celsius. Then you keep reading. If 25 grams, that's your mass, is cooled, here's the key word, cooled. So your initial temperature is 35 degrees. Your final temperature is 18 degrees. To get your delta T, it's T final minus T initial. So by doing that, you're actually going to end up with a negative number because you're going to go 18 minus 35, and that will be a minus 17 degrees Celsius. So you got to get careful there. And then you're going to plug it in. You're looking for Q. And you're going to use the equation Q equals mCp delta T. Because you've got a negative number here, Q needs to be negative. Okay? Yes?
So delta T is just that temperature change?
It's a temperature change, but it's final minus initial. You need to make sure you put it in that way. Okay? Otherwise, you're going to get messed up. So that was number 2. And I had a lot of questions on number 6. So I did not finish this one for you. I set it up and told you what you need to do. So make sure you fix it. Remember that Q should be a negative, and it should be joules as the unit. Don't forget the units. On number 6, this is one that a lot of kids have been having problems with because it's a little bit different. So let's talk about it. As you read it, it says, if a mass of 335 grams at 65 degrees, so that's my temperature initial, loses, my Q, loses means negative, 9,750 joules. What is the final temperature, TF, question mark, of the water? Liquid water has a specific heat of 4.184 joules per gram degree Celsius. So this one you actually got to take in 2 steps. We can't find delta T because delta T is TF minus TI. And we only have TI, right? But I can put it into the equation, Q equals mCp delta T, and solve for delta T. And then I can plug it into this equation to find the T final. So you're going to do 2 steps. Plug it in first. Remember to put the negative 9,750 joules equals, actually, let's rearrange it first. Remember, I like to circle what I'm looking for, divide both sides by everything else to get what I've circled by itself. So over here, that would cancel this out, and I would have delta T equals Q divided by mCp. Remember, that needs to be in parentheses. Plug in what you got. So I'll end up with negative 9,750 joules. Sorry, that didn't write very well. Times by 335 grams times specific heat 4.184 joules per gram degree Celsius. By doing that, joules cancel, grams cancel, we end up with degrees Celsius. And it's going to be a negative change. That's going to be important. So when we put that in, we're going to have a negative delta T that we put in here that we solved for is equal to temperature final minus our 65.5 degrees Celsius. And then we're solving for delta T final. Okay? So you're going to have to do a little bit of calculations. So negative delta T, whatever it was from up here, comes in here, and T final minus 65.5 degrees Celsius. I've had a lot of kids try and multiply or divide both sides by that. Guys, it's adding. All you have to do is add 65.5 degrees Celsius to both sides. Over here, it cancels out. Over here, you'll end up with what TF is. Okay? You need to be able to do one of each of the problems on assignment number 4. It's what you're going to see on the test. Okay? Different numbers, but basically the same kind of thing that you need to do. All right, questions about that? Okay, let's go to your lab. Pull your lab out because we're going to pull it around with you when we go to speed dating. So on your lab, let's see, I've got it right here. Bring it up. Make it a little bigger. Okay, so on your lab, you should have had the first page done. The second page, these are going to be important. So if you just take and fold your lab paper out, so this page is showing and this page, then you can quickly do it. You're going to be pulling off the page before, like here's number 4. I'm going to need this one. I'm going to need 10. So 4 here. It's not going to go. There we go. 4, 10, and whoops, 8. So I'm going to take 8 from there. That's going to be on the top. And then I divide it by, let's see if it lets me change colors. Maybe, maybe not. Okay, then on the bottom, nope, it's still black. Come on. On the bottom, you're going to put 1 and 9. So you're going to times 1 and 9 on the bottom. So this one and 9. So the black ones I'm going to times together on the top, divided by parentheses, the red ones on the bottom. But I want you to go ahead and write that out, those numbers out right here. So you're going to go this time. Oh, I love this when it does that. Come on. It's one bad thing about having it in Word. Okay, so you're going to have this times this. So number 4, whatever it is, from the first column, times number 10, whatever it is, from the first column, times whatever it is, 8. Put this in. Number 1 times number 9, and make sure on the bottom that, well, that didn't work, that we put parentheses around that. So divide parentheses and then hit equal. You're going to show me the work on both of these. These numbers, this one goes here, and this one will go here. Okay? Now, identity of the sample is from your first number 1, I think it is on the first 2 columns, actually above number 1. It says identity of metal sample. You're just pulling that in. Was it copper, zinc? What was it? Can you put that away? Okay. All right, quickly finish and then help us. The literature value is just right above that. Okay? So you're going to pull it right off of that chart and put it down in here. Then all you're doing at the bottom, whoa, come on. I love this. It's so much fun. All you're doing down here at the bottom is you're going to take the literature value minus the experimental, which is this one, get a number, divide it by the literature value, and then times it by 100. You want this number to be less than 20%. If it's not, then you're going to have to explain it on the next page, right here underneath error analysis. That's where you explain that error. On the conclusion up above, it wants you to use your data. Data is from the chart that you wrote down in lab. That's this. So in your data, show me what's going on. Tell me what happened. Tell me what things went on. What things were important that you got from lab. Okay? Then in your error analysis, you're using these numbers right here to say, this was my error, this is how I think what I might have done that caused that. Okay? Questions on write-up for lab? Okay, so when you finish what I ask you to do in the speed dating, and you still have time left, you're working on finishing your lab. So as we go to speed dating or speed probleming, I want you to take your lab with you, your notes with you, and your assignment page with you. Okay? And we'll do that after we correct. So I'm going to stop right now, give you 5 minutes, so those that were struggling with the assignments can finish those 2 problems if you haven't already got them fixed. Make sure you've picked up a brown paper or brown pencil at the back we're going to correct the assignment with. And then in 5 minutes we'll come back, we'll correct it, and we'll then start going to speed probleming.